Alright, so here's our review for our test. We'll start with these inequalities. Once again, when you have a fraction, I'm a big fan of multiplying by the denominator to everything. And we're left with 3x. Ooh. Let me change this so I am not writing it too big. Okay, so we're left with 3x plus 28 is greater than 63. 3x is greater than, we subtract 28 on both sides, we get 35, and my x is greater than 35 over 3. Now, I have to graph that on the number line, so I'm always going to put my 2 spots there. Okay, we're going to do 0, 35 over 3. Because it is greater than, it is an open dot, and we are going to the right. And because it's greater than, it's a parenthesis for my set notation. So 35 over 3, and then comma, infinity. And that's my first answer, and all of this is part of the answer. And my second one is going to be 6x plus 30. We're distributing, and it's less than or equal to 11x minus 17. I'm going to move the 11x over. I always like the x on the right, even if it makes it negative. I'm going to subtract 30 on both sides, and I'm going to get negative 47. So my answer is going to be, x is, now we flip the sign, because we're dividing by negative there, 47 over 5. I come to my number line, put my 2 spots here, we get 0, we get 47 over 5, and then from there, we have a closed dot, because it's greater than or equal to, and my line is going to the right. For my set notation, it's a bracket. So it's 47 over 5, comma, infinity, and then the parenthesis around the absolute value. A parenthesis around the infinity. Now for here, we're going to multiply everything by 7. Even though the fraction is negative, we keep the denominator positive. So this becomes negative 6x plus 35 is greater than or equal to 16 times 7, which is 102. Actually, nope, 112, excuse me. 16 times 7. Yeah, 112. Okay. So from there, we're going to subtract 35. And my answer is going to be negative 6x is greater than or equal to 77. And when I divide, I can't reduce this, but because I'm dividing by a negative, the inequality flips, and we're left with negative 77 over 6. When I go to graph it, we go here, and it's a 0, and it's a negative 77 over 6. That becomes a closed dot because it's less than or equal to, and we're going toward negative infinity. So a parenthesis, negative infinity, comma, negative 77 over 6, and that number gets a bracket. Finally, our last one here is going to be 4x is less than negative 32. When I divide by that 4, remember the sign does not flip because I'm not dividing by a negative, even though there's a negative in the numerator. My answer is simply x is less than negative 8. So we get a 0, we get a negative 8, we get an open dot, and we go to the left. And then we get a parenthesis, negative infinity. And because it's just less than, we also get a parenthesis around our negative e. And these are our answers. Circle that one. And these are our answers here. Remember, you need to solve the inequality as well as graph it on a number line, as well as put it in set notation. Now here we need to write the inequality before we can solve it. You make a base salary of $40,000 and you get 4% commission on everything. And you want to make more than $75,000. You have to actually be more, so it's just a greater than sign. So this becomes 0.04x is greater than 35,000. We do 35,000 divided by 0.04, and that leaves us with 875,000. So if you want to make more than 75,000 for the year, you need to sell $875,000 worth of stuff, because 4% of that will get you to the extra 35,000 you need. Now keep in mind, they want the amount you sell per month. So per month, you would need to be greater than 875,000 divided by 12. So that's 875,000 divided by 12, which leaves you with a per month of, you need to be greater than 72,916.67. When you're solving an inequality proportion, the key is to keep the numerators to the left. It's 8 times 5x minus 3 is greater than 6 times 9x plus 2. We get 40x minus 24 is greater than 54x plus 12. I'm going to get negative 14x is greater than 36. And when I divide both sides by a negative, the inequality flips, and I'm left with negative 36 over 14. And I would reduce that. Negative 18 over 7 is my answer. When solving absolute value problems, we've got to get the absolute value alone. So it first is 4 3x plus 7 is in the absolute value. We're going to subtract 8 on both sides, and we're left with 24. Now I need to divide the 4 out of there, and now I'm left with 3x plus 7 is equal to 6. So if you notice, we're getting the absolute value alone. And then we set up two equations. We set it equal to negative 6, and we set it equal to positive 6. 3x equals a negative 13. 3x equals a negative 1. X equals negative 13 over 3. X equals negative 1 over 3. And those are my answers. Same deal here. And it does not matter that there's a negative in the absolute value. That's irrelevant. Okay, you can have a negative in the absolute value. 5, negative 2x minus 4 is going to equal, when I subtract 8 on both sides, 15. Then I'm going to divide both sides by 5. So now I'm left with 3. And now I'm setting them both equal. Negative 2x minus 4 equals a negative 3. And negative 2x minus 4 equals a positive 3. Negative 2x equals 1. Negative 2x equals 7. So my two answers are negative 1/2 and x equals negative 7/2. Now, absolute values with inequalities, we're always going to set up either two equations or a combined statement. When it's a greater than or equal to, it's a combined, it's two equations. So we're going to have less than or equal to negative 11 and 3x plus 5 is greater than or equal to 11. 3x is less than or equal to negative 16. 3x is less than or equal to 6. And then when I divide them, x is less than or equal to negative 16 over 3. And here, x is greater than or equal to, sorry, that's a mistake. That should be a greater than sign there. Apologize for that. This should be x is greater than or equal to 2. Now when I go to graph it, every greater than graph is going to look like this, where you have negative 16 over 3 here, 0, and 2. Since it's greater than or equal to, it's a closed dot, and we're going to the right. It's a closed dot at negative 16 over 3, and we're going to the left. And our set notation is going to be negative infinity to negative 16 over 3 with a bracket, and then a bracket around 2 because it's greater than or equal to infinity. Remember, greater than or equal to gives you brackets, greater than or less than gives you parentheses. I'm going to do the other greater than right now. Okay, the other greater than, which is right here, we're going to go with 8x minus 3 is less than 15. 8x minus 3 is less than negative 15. 8x minus 3 is greater than 15. So 8x is less than negative 12. 8x is greater than 16. And x is less than negative 12 over 8, which reduces to negative 3 halves. And x is greater than 2. And those are my two answers. We go here, here, and here. Negative 3 halves, 0, and 2. And because it's just greater than, they're open dots, going in opposite directions. And my set notation, negative infinity to negative 3 halves, and then 2 to infinity. And notice both greater thans look like this. The only difference is the closed dot in the brackets. When it's a less than, we write a combined statement. It becomes negative 11 less than 4x minus 7 less than positive 11. Add 7 to both sides, negative 4 less than 4x, 18, negative 1 less than x, 18 over 4 reduces to 9 over 2. And that graphing goes a little quicker because you're just putting it between two numbers. So we get negative 1 over here, 0, and our 9 halves. Since it's a less than sign, the dots are open. And now it's parentheses because it's a less than sign. Negative 1, 9 halves. The bottom one is a less than or equal to sign. So that one becomes negative 39. So it's negative 39 less than or equal to 9x plus 6 less than or equal to 39. So it's negative 45 less than or equal to 9x less than or equal to 33. And then that becomes negative 5 less than or equal to